Hello students, welcome to Vyas Edification Kota. In this series of NCERT discussion, it is time to continue further with Mathematics class 11, the chapter Permutations and Combinations, and right now we are dealing with miscellaneous exercise. Yes, the very important miscellaneous exercise from chapter number 7 will be discussed over here. Let's discuss the first question. The first question says, how many words without meaning, each of two vowels and three consonants, can be formed from the letters of the word daughter? Okay, let's see where does this question take us. So daughter, if you are interested in vowels and consonants, let's write the vowels and consonants separately. D, A, U, G, H, T, E, R. I hope there's no mistake in this. Yeah? These are all consonants. These are all vowels, right? G, T, G, A, E, I, O, U, right? Over here. And how many letters do you get? These are 5, 6, 7, 8 letters. There are 1, 2, 3, 4, 5, 6, 7, 8 letters here as well. Yes. So count is correct and we have written the vowels and consonants separately. That's the first stage. Next, with or without meaning, you are supposed to form words each of two vowels and three consonants. Okay. Select three consonants and select two vowels from here. Okay. And then we are supposed to form words. Okay. So first we'll select three consonants. How many ways of selecting three consonants? You can select three consonants out of 5 in 5C3 ways. You can select two vowels out of 3 in 3C2 ways, and then you can form words. Once you have selected these three consonants and two vowels, you'll form words by arranging them. So 5 things have to be arranged at 5 places. In 5 boxes, you'll be arranging these things. So that will be equal to 5. That number of ways will be simply equal to 5 factorial. So this times this times this. Now the task is complete, and by the fundamental theorem this says this multiplied by this multiplied by this will give me the final value, right? This is what you have. So 5C3, the value of 5C3 is same as 5C2, which is 5 times 4 over 2 times 1. 3C2 is same as 3, 5 factorial is 120. This is 10 actually, and 10 times 120, basically 12 times 3 is 36, and then you have 2 zeros. This is my answer for this question. These many words can be formed using these ideas, right? That's all you have in this question. Moving on to the next one. Second question says, how many words without meaning can be formed using all letters of the word equation? All letters of the word equation at a time, so that vowels and consonants occur together. So vowels occur together and consonants occur together. Let's write them together first. Equation. We have E, Q, U, A, T, I, O, N. Vowels and consonants, right? First we'll write them separately. Then the number of ways, so that using all the letters, the vowels come together and the consonants come together. That's what the person is saying, right? So there are actually 2 bags, and the ways of arranging those 2 bags at 2 places will be 2 factorial, right? Then what next? This particular bag of vowels, let's say this is the bag of vowels, these vowels will get rearranged among themselves, right? And that arrangement will be how many ways? That arrangement will be actually, there are 5 vowels, so there will be 5 factorial ways of arranging the vowels at that location. Similarly, the consonants can be arranged in 3 factorial ways, and this is the total number of ways. That is what we can. These are the number of words that can be formed. This is 2 factorial is 2, 5 factorial is 120, and 3 factorial is 6. So this is 12 times 12, which is 144, and you have a 0 as well. That's my required answer for this question. That's all. Yes, that's just all. Let's move on to the next one. Third question. The third question says, a committee of 7 has to be formed from 9 boys and 4 girls. Okay, so you have 9 boys, 4 girls, and a committee of 7 is to be formed. Okay. In how many ways can this be done when the committee consists of, mind you, exactly 3 girls, at least 3 girls, at most 3 girls, or all different parts? So let's talk about the first part. For selecting a committee of 7, you have exactly, if you have exactly 3 girls, so you select 3 girls, and how many boys? You select 4 boys. That's the case, right? So selecting 3 girls out of 4 girls will be 4C3. Selecting 4 boys out of 9 boys will be 9C4. And number of ways would be this. This is the number of ways. Is this 4C3 times 9C4? What is that? This is 4. 9, 8, 7, 6, 4, 3, 2, 1. 4 goes over here. 3 times 2 is 6. And this is 9 into 7, 63 and 8. This is actually 8 cube minus 8, which is 504 is the answer for this question over here. That's the number of ways. Next, in the second part, you're asked that at least 3 girls are selected, right? So you can actually make a selection of 3 girls, 4 boys to give you a committee, or you can select, since the person says at least 3 girls, that means you can select more girls, right? So you can select maybe 4 girls, and along with 4 girls, you have to form a committee of 7, so you'll select 3 boys. Or maybe you can select 5 girls as well. But are there 5 girls available? No. There are only 4 girls. At max, you can select 4 girls. That's what you have done, right? So 3 girls plus 4 boys, or 4 girls plus 3 boys. That's what you have, right? Number of ways will be equal to what? Number of ways for this one will be, you have to select 3 girls out of 4. This is 4C3 times, you have to select 4 boys out of 9. This is 9C4, right? And after doing this and this, your selection is complete. That's done. Task is complete. Oh, but then the other, or this is also there. So you have to select 4 girls out of 4, and you have to select 3 boys out of 9. This is the other way, and this in itself is a complete selection, right? By the fundamental theorem, we know that this task complete, this task complete. Okay, this is a separate case, this is a separate case. We'll have to add these two and to get the final answer, final number of ways. 4C3 into 9C4. Can I copy that from here? Yes, this value is 5C4 plus 4C4 is simply 1, and 9C3 is 987 over 321. This is what you have, right? So 987 is, let's say this is 3 and this is 4. So 4 times 3 is 12, times 7 is 84. This is 504 plus 84, which is 588 ways. That's my answer for the second part over here. That's the answer for the second part over here. What about the third part? In the third part, the person has asked us to select the committee such that committee consists of at most 3 girls. Now, at most 3 girls will be slightly more interesting. Let's see the idea behind at most 3 girls. Let's get rid of this place over here. And I have what I have in the original question. It is given that you have 9 boys and 4 girls available, and you have to select a committee of 7. That's your target, right? Let me write the target there. And talk about the first part after this. Third part after this. Third part, first and second we have already solved. Let's talk about the third part. At most 3 girls would imply what? That you can select 3 girls plus, for making a committee of 7 you need 4 boys, right? 3 girls and 4 boys. Or at most 3 would imply that you can select a lesser number of girls, right? So let's select maybe 2 girls plus 5 boys to create a committee of 7. It can be done, yes. Or for that matter, you can select even lesser number of girls, 1 girl plus 6 boys. Okay, even lesser number of girls. Is that possible? You have a total of 9 boys. Yes, that is also possible. Or you can go ahead and select maybe 0 girls and 7 boys as well. That's another way of selection, right? So there will be 4 different cases. Yes, there will be 4 different cases in this manner. Right. So next, once we know that these will be the 4 different cases, let's calculate the values. So number of ways will be equal to what? 3 girls and 4 boys. So out of 4 girls, 4C3 times 9C4 is what I get, plus, since this is an or, we've already understood the logic behind or. Fundamental theorem says that you'll have to add the other cases. What is that? 2 girls out of 4 girls, 4C2. 5 boys out of 9 boys, 9C5 is what I get, plus. Since there's another or, 1 girl will imply 4C1 times 9C6 plus another one. What's that? 0 girls, which is 4C0 times 9C7 is what I require over here. Yes, this is what I need. Let's multiply and then add the corresponding numbers. What is this? 4C3 and 9C4. Okay, 9C4 and 9C5, are they exactly same? Yes, 9C4 and 9C5 are exactly same. 4C3 times 9C4, this is something which I have already calculated, but I remember that 4C3 is 4, 4C2 is 6, so this will add up to 10. 10 times 9C4 or 9C5 are exactly same, right? So this is actually 4C3 is 6, 9C4 will be 9, 8, 7, 6, 4, 3, 2, 1. 4C2 is, sorry, 4C3 was 4, not 6. This is 4. 4C2 is 6, that is 4 times 3, 12 upon 2, 6. Times 9C5, which is same as this is 9, 8, 7, 6, 4, 3, 2, 1. Plus 4C1 is 4, 9C6 is what? 9C6 is same as 9C3, 9, 8, 7 over 3, 2, 1 plus 4C0 is 1 and 9C7 is same as 9C2, which is 9 times 8 over 2 times 1. This is what you have. These are the numbers, right? Now what do these numbers simplify into? This is 4 times 2 is gone with this 8. 3 times 2 is what I get over here. I'm not cancelling this 4 because I want to add these 4 and 6 together by taking out this factor common, right? I want to add them together, and what will remain is 4 plus 6 is 10 times this number. Now what is this number? 9 times 7 times 2 is 14, 14 times 9 is 126. This is what I get by adding these two terms together. Plus, what about the other one over there? This is 3 times 3, this is 2 times 4, okay? And what you get is, this is 7 times 3 is 21, 21 and times 4 is 84, 84 times 4 is 336, 336. Let's calculate that again. Let's calculate another way. 4 times 3 is 12, 7 times 4 is 28. Okay, 4 times 3 is 12, times 4 will be 48. 48 times 7, 56 and 5, 7, 4, 28 and 5, 33. This is 336, right? Okay, what about the last one? This is 4, so 9 times 4 is 36. This is what I'll be getting. This here is 1260 plus 372 is what I get, and the total number of ways using this will be 372 and 1260 will be 2, 3 and 16. 1632 is the answer for this question. So this is the number of ways of selecting this committee of in the third part it is asked at most 3 girls. You can take a look at the complete solution of first, second and third part written over here. I'll get a side, and that's the complete solution for this question, as you can see. Moving on to the next one. This. If the different permutations of all the letters of the word examination are listed as in a dictionary, the person says different permutations of all letters of the word examination are listed as in a dictionary. How many words are there in this list before the first word starting with E? Okay. Now when you want to list all the words as in a dictionary, you'll have to write the letters of the given word in alphabetical order first of all. Write in alphabetical order because dictionary says alphabetical order, right? So we have EXAMINATION. First, let's see if there is any repetition, and simultaneously we'll also write in order. So E, X will come later. A, EXA, M, I, N, A, T, I, O, N. There's another N. Let's write another N over here, right? This is what you have. These are letters written in the alphabetical order. Do you observe that, right? Let's see. Let's write in this manner. Actually, A, E, I, M, N, O, T, X. These are the letters that we have. A is repeated, I is repeated, N is repeated, O, T, X are not repeated. And how many letters in all do we have? 2 plus 1, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, we have not missed anything, and that's a good thing, right? Okay. So next, different combinations of all the letters of the word are written as a dictionary. How many words are there in this list before the first word starting with E? So before the first word starting with E, there will be words starting with A. Okay, there will be words starting with A. Let's see. So words starting with A is what we are supposed to count. Number of words will be actually words starting with A only, and for fixing that A, and then there are 11 places which need to be filled. after A. There are 11 places which need to be filled. Since there are a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh, just a minute. 5, 6, 7, 8, 9, 10, 11. Okay. There are a total of 11. You have fixed A, so you need to fill 10 more places, right? Only 10 places more. And number of words would be equal to this. 10 places have to be filled by 10 letters. So the number of A's will be 10 factorial. But there are certain repetitions, right? N is repeated, I is repeated. A was also repeated. No. Don't make a mistake in that. You have already used one A and now only one A is remaining in these 10, right? So that repetition of A is not there. You have only repeating I's and repeating N's. That's what you get. So 10 factorial upon 2 factorial, 2 factorial. And what's that value? Let's calculate this value. This is 10, 9, 8, 7 and 6 factorial is 720. That's something which I remember. 2 times 2 is what I have, right? So 2 times 2 will be 4 and this goes over here. 9 times 7 is 63 times 2 is 126. Okay. 9 times 7 is 63, 126. 1260 times 720 is what I need. So let's multiply this 126 and 72. Okay. Let's multiply them together. This is 6 times 2 is 12. You carry forward a 1. 2 times 2 is 4. 7 times 6 is 42. 42 plus 4 is 46 plus 1 is 47. You carry forward a 1. 2 times 7 times 2 is 14, 15, 16 and 20. You carry forward a 2. 9072 is what I get. 9072 00 is what I get. 907200 is the number of words starting with A, which come actually before the first word starting with E. That's what you have, right? And that's the final answer for this question over here. Let's discuss this question next. How many 6-digit numbers can be formed from the digits 0, 1, 3, 5, 7 and 9? Okay. 6-digit numbers. We are supposed to form 6-digit numbers from the digits 0, 1, 3, 5, 7, 9. Okay, there are 6 digits which are divisible by 10 and no digit is repeated. Okay, no repetition. Okay, and you have 6-digit numbers. So you need 6 boxes. And these boxes have to be filled with all of these numbers. There's no repetition, right? Divisible by 10. Now what does divisible by 10 imply? That this particular will have a 0, right? For divisibility by 10, this should be 0. So 0 goes over here and the remaining 5 have to be arranged at these 5 places. The number of ways would be 5 factorial, which is simply 120, and that's the number of numbers that can be formed using this, right? 6-digit numbers are formed using this idea. That's the only thing that you need to do, and that's all in this question. Moving on to the next, 6th. The English alphabet has 5 vowels and 21 consonants. Yes, we know that. How many words with 2 different vowels and 2 different consonants can be formed from the alphabet? Okay. So out of 5 vowels, you can select 2. Out of 21 consonants, you select 2. You get 2 vowels, V1, V2 and 2 consonants, C1, C2, and they are different, so you arrange them to get different words. You arrange them, the 4 elements can be arranged, 4 things can be arranged in 4 factorial ways. The number of ways, the number of words that can be formed is this. 5C2 is 10, 21C2 will be 21 times 20 over 2 times 1, and 4 factorial is 24. Okay, this is 10, right? So this becomes 100 times 21 times 24. And can we multiply 21 and 24? Yes, we can do that. This will be equal to what? 4 times 1 is 4, times 2 is 8, 9, 10, 0, 1 carry, and 5, 0, 4, 00 is what I get. This is my answer for this question over here. Let's move on to the next one. 7th. The question says, in an examination, a question paper consists of 12 questions divided into 2 parts. Okay. 12 questions divided into 2 parts, part 1 and part 2 containing 5 and 7 questions respectively. This has 5 questions and this has 7 questions. Okay, given. A student is required to attempt 8 questions in all. Okay, select 8. Selecting at least 3 from each part. Okay, at least 3 and at least 3 from each part. In how many ways can a student select the questions? Okay, now that's interesting. We have various ways. In the first part, you have 5 questions, out of which at least 3 should be selected, and out of 7, at least 3 should be selected. But total have to be 8, so we can select more from here and maybe more from here as well, right? So number of ways will be equal to what? For finding the number of ways, let's see what kind of selections do we want to make. In the first part, I can select 3 questions. If I select 3 questions from the first part, what I need to do from the second part is I need to select 5 questions to make the total selection 8, right? So 3 plus 5 is what I need, right? That's one selection. From the first part you select 3 questions, from the second part you select 5 questions. Or let's select more questions from the first part. You can select 4 from here and 4 from the second part. 4 from here and 4 from here are possible, yes. Or you can also select 5 from this and 3 from the second part. 5 from this and 3 from this are also possible. Are 6 selections possible from this? That's not possible, right? So those are the various cases. Selecting 3 out of 5 would imply this is 5C3, and selecting 5 out of 7 would be 7C5. And we'll have to multiply this because both of them are required. This and this has been done. This is a separate case. Let's add them. What you get is 5C4. Select 4 out of 5 and select 4 out of 7. Let's multiply it here also. Or implies this is a separate case. Let's add them, and selecting 5 out of 5 would be 5C5. Selecting 3 out of 7 would be 7C3. This is what I get, right? Check the numbers over there. If you have written this correctly, after this the only thing that remains is calculations, right? The concepts of P and C will take you here, and after that you can do the calculations. 5C3 is same as 5C2, which is 10. 7C5 is same as 7C2, which is 7 times 6 over 2 times 1, plus 5C4 is same as 5. 7C4 is same as 7C3. 7C3 is 7, 6, 5, 3, 2, 1, plus this is 1 times 7C3, 7, 6, 5 over 3, 2, 1. This is what we have, right? Is that okay? Yes. 6 is gone, 3 times 2, 6 is gone, and this is 3. So 7 times 3 is 21. This is 210 plus. What is this? 7 times 5 is 35 times 5, and 7 times 5 is 35. You get actually 35. You can take out 35 common. You get 5 plus 1 in the bracket, right? This is 210. Okay. Plus 35 times 6 is what I'm getting, right? Which is 210 again. 35 times 6 is 210. This is 420. So there are actually 420 ways of selecting the questions from this question paper, so that you can select 8 questions with the given conditions, right? That's a complete solution for this question over here. Let's move on to the next one. The 8th question says, determine the number of 5 card combinations. 5 card combinations. Out of a deck of 52 cards, if each selection of 5 cards is exactly 1 king. Okay, so from 52, there are 4 kings and 48 other cards. There are 4 kings and 48 other cards. 5 cards have to be selected. Select 5 such that there is exactly 1 king and 4 other cards will be required, right? So number of selections would be, now this question is similar to one which we have seen in the previous exercise. There you were required to find the number of aces. So select ace, actually exactly 1 ace. So this is 4C1 into 48C4. Okay, that's the number of ways, and you can leave the answer at this stage, or you can actually calculate. NCERT people want you to calculate. If they want you to calculate, you can also calculate this. How do we do that? This is 4. Okay, 48C4 will be 48, 47, 46, 45 over 4, 3, 2, 1. 4 goes over here. 3 times 2 is 6 times 8 is what I get. Okay, 8 times 45. Now that can be calculated easily. This is 90 times 4. This is 360. And 46 times 47. Let's multiply that together. We get 7 times 6 is 42. 2, 4 carried. 6 times 4, 7 times 4 is 13 times 4, which is 52, and 4 is 56. 6, and you carry forward a 5 and 21. This is what I'm getting, 2162. Let's check that again. 7 times 6 is 42. 4, 24, 28, and 32 is 28, sorry. 6 times 4 is 24 and 7 times 4 is 28. So 24 and 28 will be 52, and you carry forward this 56. 5, 4 times 4 is 16 plus 5 is 21. 2162 times 360. That's what you need to calculate. And what's that? 2162 times 36. 6 times 2 is 12. Okay, you carry forward a 1. 6 times 6 is 36 plus 3 times 2 is 6. 36 plus 6 is 42 plus 1 is 43. 3, you carry forward a 4. 6 times 1 is 6 and 6 times 3 is 18. 24 plus 4 would be 28, 8 and you carry forward a 2. Okay, 6 times 2 is 12 and the thing is, 3 times 1 is 3. 12 plus 3 is 15 plus 2 is 17. So 7 and you carry forward a 1. 3 times 2 is 6 plus 1 7. So 7, 7, 8, 3, 2 is what I get. 7, 7, 8, 3, 2, 0 is the final answer for this question over here. This or this, right? Both of them are the same. That's the complete solution of this question. Let's move on to the next one after this. 9th. It says it is required to seat 5 men and 4 women in a row. Okay. So that the women occupy the even places. How many such arrangements are possible? Okay. So you have 5 men and 4 women. You have a total of 9 persons. Okay. 1, 2, 3, 4, 5, 6, 7, 8 and 9. Right. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9 places, out of which this are even places. And it is given that, it is said that the women occupy even places. How many women are there? There are 5 men and 4 women. Okay. So 4 women can be arranged on exactly 4 locations in this way. And the remaining 5 places will be there for 5 men. So number of ways would be equal to what? Number of ways will be simply equal to arrange 4 women at 4 places, arrange 5 men at 5 places. This and this is required, right? 5 men, 4 women. Women occupy even places, and how many such arrangements? This. What is that? 24 and this is 120. What is that equal to? This is 12 into 12 is 144 into 2 is 2880, and yes, that's my answer for this question over here. Let's move on to the next one after this. 10th. The 10th question says, from a class of 25 students, 10 are to be chosen for an excursion party. Okay. There are 3 students who decide that either all of them will join or none of them will join. Okay. And how many ways can the excursion party be chosen? Right. So from a class of 25 students, okay, there are 25 and 10 are to be chosen. Select 10. 3 students who decide that either all of them will join or none of them will join. Let's say there will be 2 separate ways of selecting this party of 10. That is, those 3 are surely selected. 3 are in, and you need an additional 7 out of 25. Out of the remaining, right? Out of the remaining. Or 3 are out and you need 3 are out and you need all 10 out of the remaining, right? So the number this or this is what will happen, right? This case is separate, this case is separate. If you have selected those 3 people out of 25, there are 3 and remaining 22. If you have selected 3 out of 3, that is actually 3C3 ways. Number of ways will be 3C3 and into you'll have to select 7 out of the remaining 22. This is 22C7. Okay, that's the number of ways for this particular case when those 3 are chosen. Plus, because of this or, if those 3 are excluded, you have to choose the remaining 10 from these 22. Out of these 3, none are chosen, 3C0, and out of 22 you select 10. So this is 22C10. The number of ways would be 22C7, 3C3 times 22C7. This is 1 and this is 1. This is 22C10. Okay, 22C7 plus 22C10, that's the number of ways. And will we calculate this? 22C10 will be very ugly. No, we'll not calculate this. We'll leave the answer at this stage. If you want, you can calculate this value on your own. Try it in your copies, right? That's the answer for this question over here. Let's move on to the next one. This 11th. In how many ways can the letters of the word assassination be arranged so that all the S's are together? Okay. We have assassination, A, S, S, A, S, S, I, N, A, T, I, O, N. Okay. So how many letters do we have? We have 3, 7, 8, 9, 10, 11, 12, 13, 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, right? So we have not missed anything. These are 13 letters and there are also 30 letters. Letters of the word this be arranged so that all the S's are together. Okay, all the S's have to be clubbed together and kept in a bag, right? So we have one bag. 3 plus 1, 4, 5, 6, 7, 8, 9, 10. 10 elements at 10 places would be 10 factorial ways. The number of ways would be 10 factorial, but there is a repetition, right? Repetition of 3 A's, so you divide by 3. Repetition of 2 I's, you divide by 2, and repetition of 2 N's, you divide by 2. And that bag containing S, 4 S's, that will be arranged at a place, and these 4 S can be arranged, but then their arrangement will be, the number of ways of arranging them will be simply 4 factorial by 4 factorial, or that is 1. The number of ways of arranging this bag will be 1. Right. So this is the number of ways. What is that equal to? Let's find this value. This is 10, 9, 8, 7, 6. Oh, and then you have 120. 5 factorial is 120, right? This is 6 times 2 times 2. Okay. 6 goes with 2. 6 goes with 6. 2 times 2 is 4. This goes over here. And what do we get? This is 9 times 7 is 63. Okay, 10 is there, you have a 63, you have 2 times 12 which is 24 and 240 is what I get. Right, let's multiply them together further. 63 times 24 is simple, 4 times 3 is 12, okay, you get 2 zeros at the end, 4 times 3 is 12, you carry forward a 1, 6, 4, 24 plus 6 is 30, 31, you carry forward a 3, 15, 151200 is my answer for this question. 151200 is the answer for this question over here, as you can see behind me. With this, we come to the conclusion of this exercise, the miscellaneous exercise based on permutations and combinations. And yes, this is the end of this chapter of permutations and combinations.